Okay, get this. What if I told you that the very same Wi-Fi signal that's probably beaming this to your device right now could also be used to see through solid walls? I know, it sounds like something straight out of a superhero movie, but it's not. Researchers at MIT have actually figured out how to do it. It's real, and we're going to break down exactly how they pulled it off.
So let me just ask you this straight up. Could that little blinking box in your living room, your Wi-Fi router, be tracking your movements at this very moment? Not just in the same room, but through a wall? Well, the answer is kind of shocking. Yeah, it can.
And this is what it looks like. This image is from the actual experiment. They call our system Wi-Fi, which is short for Wi-Fi vision. Now, that colorful blob you're seeing, that isn't a heat signature. That is a person's location, and you're watching them move over time, all captured from the other side of a wall using nothing more than Wi-Fi. So, how in the world is that even possible? Well, the basic idea is actually pretty simple. It's kind of like radar, you know? A signal goes out, it passes through the wall, bounces off of you, and then comes back. But there is one massive, almost impossible challenge they had to solve first. They call it the flash effect. You see, the signal that bounces off the wall itself is thousands, sometimes even tens of thousands of times more powerful than the tiny, faint signal that actually makes it through the wall, reflects off a person, and then makes it all the way back out. That reflection from the wall is so loud, so powerful that it completely drowns out everything else. The researchers have a perfect analogy for this. Just imagine you're trying to take a photo of someone who's standing behind a big mirror. If your camera's flash goes off, the reflection of that flash on the mirror itself would be so incredibly bright that your camera's sensor would just be totally blinded. You wouldn't see a single thing behind it. That is the exact same problem they face with Wi-Fi. So how do you get around a problem like that? Well, the first part of their solution is just genius. Instead of trying to somehow see through that blinding flash, they just figured out a way to, well, to make it disappear. They use a really cool technique called MIMO interference nulling. The goal is to basically cancel out every single signal that's bouncing off of things that aren't moving. So the wall, any furniture in the room, all of it. You can think of it just like your noise-canceling headphones. They create an anti-noise signal to block out the drone of an airplane engine, right? Wi-Fi does the exact same thing, but for Wi-Fi reflections. It's this clever little three-step dance. First, the device uses two antennas to measure that static echo coming from the room. Then, it does some quick math to calculate the perfect anti-echo signal needed to cancel it out. And finally, it transmits both signals at the exact same time. At the receiver, they perfectly cancel each other out. And that massive reflection from the wall, it just vanishes. Poof, gone. And the results are just staggering. On average, this technique crushes the power of those static reflections by 42 decibels. Now, if you're not an audio engineer, that number might not mean much, but trust me, it's huge. We're talking a reduction of more than 10,000 times. With that blinding flash completely gone, suddenly the super faint reflections from a person moving around become crystal clear. Okay, so problem one solved. The flash is gone. But traditionally, see-through wall systems like the ones the military uses are gigantic. We're talking about needing an antenna array that's like 8 feet long just to pinpoint a target. So the second big innovation here does away with all of that. Instead of needing this massive physical piece of hardware, they borrowed a technique from planetary mapping called inverse synthetic aperture radar, or ISAR. And the core idea here is just brilliant. They use the motion of the person themselves to create a virtual antenna array in software. This diagram from the paper explains it perfectly. So on the left, that's the traditional way. You've got a whole bunch of antennas in a line capturing a signal from different points in space. Now look at the right. That's the Wi-Fi method. There's only one receiver, but as the person inside moves, that one receiver captures the reflected signal from a whole series of different locations over time. It's almost as if the moving person is building the antenna array for them as they walk.
There's a quote from the paper that just sums this up perfectly. It says, "Wi-Fi effectively receives in time what an antenna array would receive in space." It's just such an elegant software solution to what used to be a really bulky hardware problem.
And guess what? It totally works. This is the actual output from the system. On the left, you can see the track of one single person moving around, and it creates this really distinct wavy line of energy. And then, as you can see on the right, when they add a second person to the room, the system clearly picks up two separate lines. And the accuracy here is just incredible. I mean, check out these numbers. In their tests, it correctly figured out if a room was empty or had one person in it 100% of the time. Perfect score. And even with 2 or 3 people, the accuracy was still a super impressive 85 to 90%. All right, so all of that is already amazing. But this is where the whole thing gets truly mind-bending. Because the system is so precise, it opens up a completely new door. The ability to communicate through a solid wall using only your body. You heard me right, no phone, no radio, no device at all. A person inside a completely closed-off room can actually send binary messages to the Wi-Fi receiver on the outside just by moving their body in a really specific way. And the code they came up with is so simple, it's genius. If you want to send a 0, you just take 1 step toward the receiver and then 1 step back to where you started. If you want to send a 1, you do the opposite. 1 step back and then 1 step forward. That's it. That's the whole system. And here's what this system is actually seeing. When you take a step forward, it creates this positive spike in the data. When you step backward, it creates a negative one. So a positive spike followed by a negative one gets decoded as a 0. A negative, then a positive, that's a 1. It's like a human version of Morse code. And again, this isn't just a theory. They actually did it. At a distance of 5 meters, that's about 16 feet, through a wall, the decoding accuracy was a perfect 100%. It worked every single time. Even when they moved back to 8 meters, or about 26 feet, it was still 75% accurate. Absolutely wild. So what's the big picture here? What does all this mean? This research is way more than just a cool party trick. It's really pointing to a fundamental shift in how we think about and use wireless signals. So let's boil it all down. What should we really take away from this? Well, first, these innovations could take see-through wall tech out of the military's hands and make it low-cost and accessible for everyone. Second, this opens up a whole new type of user interface, one that doesn't even need a device. And finally, this is a real glimpse into a future where our Wi-Fi networks aren't just for sending emails. They're active sensors that can see, sense, and understand the world around us. And that really just leaves us with one last fascinating thought. We just saw how these ordinary Wi-Fi signals all around us can be used to do something that seems completely impossible. And it really makes you wonder, what other incredible hidden abilities are just lying dormant inside the everyday technology that we're surrounded by? What else haven't we found yet?